Hello and welcome to very first lecture in seventh chapter of our comprehensive course on machine learning, data science, and artificial intelligence. Now, as a revision, though we have already done that in earlier chapter, I show the steps by which we navigate to our virtual environment and the proper directory and then start Jupyter notebook. If you remember, in the very first chapter, I have taught you that we have created a virtual environment named basic.ts underscore pi311. We created first one such directory, and in that directory, we created a virtual environment of same name. So here, when I write cd and that, then I have just navigated to the directory. This directory itself contains all the Jupyter notebooks and etc. If I show you that directory, then it is C and users eCube and basic ds pi311, this one. And you can see all Jupyter notebook chapter 1, chapter 2, chapter 3 and various data files and everything, they are present in that directory. Okay, so I am at present in that directory, but inside that directory there is another folder of same name, basic ds pi311. That is the folder for my virtual environment. This is that folder. So I have to go to that folder because I want to activate my virtual environment. So basic ds underscore pi311, and then I cd that is change directory to a directory called scripts, and inside the script there is one activate script, and when I activate command is executed, you can see that the prefix of the command prompt has changed. Here no prefix means I was in this environment. Now this is the prefix, so I am now in appropriate virtual environment which was specially created for my course. I give this name basic ds underscore pi311 because earlier I planned to make three courses: basic data science, intermediate data science, and advanced data science. But later on I decided that I will put everything in one course only, with of course proper gradation, and whenever advanced topic will come, students will be forewarned in advance that this is an advanced topic, so you should learn it afterwards. And this pi311 is the Python version, so we are using Python version 3.11. Okay, now my Jupyter notebook etc are not in this directory. I told you that they are actually inside C user execute this. Okay, so I have to come out of that scripts directory again. So that is very simple. Go one directory above, that means cd dot dot, and then go still one directory above, because currently I am in my virtual environment folder, and now I am in that directory. Here I am writing Jupyter Lab, and now Jupyter Lab will open in my default browser. Of course, this method will be slightly different in Linux and Mac, and I have showed the video as well as notes and Jupyter notebook also to uh, uh, for those people who are using that version. Okay, so here Jupyter Lab should start. Perhaps I gave Firefox one um, update just now, so perhaps it is taking some time, or maybe yes, it has started, but token and everything. So let me copy paste. This is not required every time. It is required just because I just now updated my Jupyter Lab. Firefox. Otherwise, this window will automatically start, and you can see if you are in proper directory, then you will see that all the chapters are visible to you. Okay, so fine. Now we want to start with this chapter, seventh chapter, data wrangling with Python. Now, what is this data wrangling? So data wrangling is one very important stage in the data science life cycle. Now, this was the entire data science life cycle. Slowly, we are proceeding further and further in this data science life cycle. So I will paste this image and the beginning of every chapter now onwards. In previous chapter also I had shown this image. Say what is the beginning of work of a data scientist? And remember, when I say data scientist, more fancier words like AI expert and the maybe machine learning expert, they are already included. So it is okay, but I will prefer to use at present only data science life cycle. So then problem identification. Now problem identification means what? Suppose a client comes to you. He is running a big firm which has a turnover of maybe 200, 300 million dollars, and he is spending at present total $40 million for publicity or marketing. He has 4 marketing channels: social media marketing channel, newspaper marketing channel, TV marketing channel, and radio marketing channel. Now, his total budget of $40 million is divided among them. Suppose he is spending say 15 million in social media marketing, 10 million in newspaper marketing. So 15 plus 10 to 25 is spending another 10 million on TV marketing. So 35, and last 5 million on the radio marketing. So 40 million is spent in this manner. Now he comes to you and he says that, am I using my budget in an optimal manner? So that means he says that I don't want to increase my budget from $40 million, but I can reshuffle. So that means if I find that social media marketing is benefiting more, then I can shift maybe some money from radio marketing, which is already less $5 million, to social media marketing, or maybe TV marketing, which is $10 million, to radio marketing. Sorry, social media marketing. So this is his problem, that his budget is like this. I will call this as okay. So his budget is $15 million for social media. Then maybe okay. So the budget total was 40 million, among which for 15 million was spent here, 15 million on TV, 10 million for newspaper, and then 5 million for the radio. This was the situation, and the client says that my business problem is that I cannot increase my total budget of 40 million on advertising or marketing beyond this. But I just want to know that where the money spent is giving maximum benefit on my sales or my profit. That means whether this money which I am spending on social media is contributing more to my sales, or this money on which I am spending on TV, or this money which I am spending on newspaper, or this 5 million which I am spending on the radio marketing. So he wants to know that which is the most beneficial marketing channel for him, because then he can reallocate his budget. If he finds that newspaper 10 million is not giving much yield, then he may make it 8 million and may make this social media marketing 17 million, or like that, keeping total 40 million constant. Now that is a business problem, and suppose the client does not understand anything about the data science. So what you will do as a data scientist, what you will do is you will first tell him that I need to understand your business. That is called business understanding. So please arrange a meeting with some senior person in your organization, and who is at the top of both sales department as well as marketing department. So after that meeting, you come out with one such equation, that sales is equal to some constant plus some other constant multiplied by TV marketing budget, plus some other constant multiplied by radio marketing budget, plus some other constant multiplied by newspaper marketing budget, plus some other constant multiplied by social media marketing budget. Okay. So these equation here, the sales is itself something called Y, unknown variable or dependent variable, while this each is itself called, say, X1, that is TV marketing budget, then this is called X2, that is radio marketing budget, then this is X3, that is newspaper marketing budget, and this is X4, that is social media marketing budget. So you have reduced the whole problem into a mathematical equation. So this is that mathematical equation. Y is for sales is equal to some constant, say B0 plus B1 X1 plus B2 X2 plus B3 X3 plus B4 X4, where this B0, B1, these are some constants which are not known, of course, and X1, X2 are the respective marketing budgets in the 4 marketing channels. Now, if I somehow find these constants B0 to B4, then I will get a ready-made equation, and in that equation I can just plug in different values of this marketing budget. Say I first plug in this original value only, that X1 is 15 and X2 is maybe 15 and X3 is 10 and X4 is 5 and whatever, and then I get the sale of that year. Okay, and then that will be a check, because that sale the person has already given to you, that when I am spending this much money, this is my sale. So you will be able to check that whether your equation, that is whether the estimated values of B0, B1, B2, B3 are accurate or not. They will never be 100% accurate, but they should be reasonably accurate. Okay. Now, once the problem is reduced to this, that is itself called this equation, that is itself called a model. So we go on speaking the word model throughout our course of data science, machine learning, my machine learning model, my machine learning model. So model is nothing but a mathematical function which relates the unknown variables like this features with my response variable y. So once these constants are found, then I can easily estimate the sales for those values of my features. Okay, but still I have taken the first example itself deliberately a little bit complicated. This does not look so simple. How to estimate these constants? So you have to, know the total sales, but you don't know for which component of sale has come because of which marketing. So you have to do customer survey. You have often seen that kind of survey. How did you come to know about us? So that kind of customer survey you can do just one line that customer has to check out of four uh, check boxes. One has social media, another has TV, another has newspaper, and another has radio. So that will give a fairly good idea that cells one, first component of cell, that is given by say this equation. I have deliberately written B00 plus B11 just to indicate that a constant would be different than the constant which are here. Okay, so this is the cells which has come due to social media. This has the component of cell which has come due to radio. This has the component of cell which has come due to newspaper, and this is the component of cell due to TV, social media. Okay, the first one was due to TV. Okay, fine. Now this is at least one dimensional equation, somewhat like y is equal to mx plus c, or y is equal to beta 0 plus beta 1 into x. So that is a standard linear equation. So I can plot the graph saying that this is my y unknown and this is my x known, because I know, at least customer knows, that in past years how much money he has spent on TV marketing. Similarly, this is also known for past years and this is also known for past years. So then I can plot the graph of y versus x for each of these. Here I have shown only one graph, but total there will be 4 such graphs, and these will be various data points. So that means I will take some arbitrary values of x1, x2, x3, and I will try to estimate corresponding values of y1, or maybe these are not arbitrary value. I will not estimate, rather these are the actual data points, red colored. So that means this is the data which the employee has given, the owner of the business has given for maybe last 4 years, or that is if it is monthly data, then last 48 months. So that is why the data points are so many. That monthly expenditure on TV, monthly expenditure on radio, they are on x-axis, and monthly sales due to TV is on y-axis. Okay, so then these are the various data points for 48 months. Okay, so I need to find a line which is approximately passing through all the data points. Now obviously no line can pass through all these data points. It would be a very curve, very freehand curve, and then also it may not pass through all. But I should try to find a line which is at least as close as possible to this data point. That means the perpendicular distance of this black colored line and this red colored point is minimum as a whole. So I have to find the distance, then I have to find, because this value, for example here, this value with this black colored dot, that is called predicted value. Why predicted? For ith observation. But this value, that is called actual value, and it is bigger. So that means in this data point my prediction has fallen slightly short of the actual value. So there some error has remained. So that is yi minus y predicted. That is called error or random error in my estimation. Similarly, but there is another data point somewhere here, and my predicted sale for that is on this black color line. The predicted values are always on black color line, because I am saying that this model predicts, this line is itself a model. So the model is predicting the my cells. So predicted values are on black color line and actual values are on this red dot. So here the prediction is slightly higher, and again I can find the difference. So you can see some positive difference will cancel some negative difference, and as a whole the total error may appear less than actually it is, because whether you overshoot your, whether your prediction falls short or whether your prediction is more than the actual value, both ways you are wrong. So what we do is we do the square of these errors and then we add it. So that concept is just like that earlier we had done that in variance, etc. So you are knowing, we whenever negative values come we square them, so that we don't minimize the error, but we minimize the sum of error, and we minimize the sum of squares of error, because there are so many data points. So we find the square of error for one data point, square of error for second data point, square of error for third data point, square of error for fourth data point. And what is error? Error is the actual value minus predicted value for any data point. It may be positive or negative, but when you square it, all squares will be positive only. Then you do sigma of all errors, and then you try to minimize it. So if your line is such that it minimizes the error, then that line is called an acceptable model. Okay, so that is, suppose this line. So I have found one such equation, and now once the line is found, it is easy. I can find the slope of that line. Slope is tan theta, and I can find the intercept of that line. So if it is this line, then this beta 0, 0, that is called intercept, and this multiple of x or multiple of this is called slope. So once slope and intercept are found, at least first puzzle is solved. First piece of puzzle is solved. Then which component of my sales comes from TV marketing? Then now I can plug in any value of TV marketing, x1, and this x1, and I can find corresponding values of sales due to TV marketing. Similarly, same linear plot I will plot for radio marketing. I will estimate the slope and intercept. Then similar plot I will plot for newspaper marketing. I will again estimate slope and intercept, and then for social media, slope and intercept. So these 4 equations are now there, and so I can combine those 4 equations into one equation. Remember, it is not so easy as just simply adding the equations, but okay, there are methods to do that. So I can get one such model which collectively tells me effect of all 4 marketing channels. So such an equation is itself called model. And when you do this, it says that this is what is nothing but converting your business problem to data science problem. Otherwise, your client came with a very simple problem that I spend this much on this channel, this much on this channel, this much on this channel, this much on this channel. I don't want to increase my budget, but I'm willing to reshuffle a few thousand, few $1 million from here to here, and that should increase my sales. So you tell me how should I reshuffle my budget? And you have found one these in which you just plug in different values of budgets one by one and estimate what would be the sales for that value, and that will give the idea when your sales becomes maximum. Okay, that will then tell that okay, social media marketing is appearing to be more effective compared to TV marketing, so shift $5 million from social media marketing to TV media marketing, TV to social media marketing. And maybe if you want, TV is the second most effective, newspaper is not much effective, so then shift $2 million from here to here. So this is only the reduction in this, it was 5 shifting to social media, but 2 more are coming back, so that means the reduction is only of $3 million. Okay, and you find that radio is effective, so maybe from newspaper you can take $1 million more. So from here you have taken 2 to TV and 1 to here, then this would become 7 million and this would become 6 million. You have solved the problem by your client. However, the question is how will you solve the problem? You have, when you make some budget with such unknowns that I don't know beta 0, beta 1, beta 2, or if I have even splitted the sales into 4 different channels, then also that is just getting proper business understanding, converting the problem to data science problem. Okay, but solving requires data. So you will ask the person that give me last 48 months of sales due to TV, due to radio, due to newspaper, and due to social media. How that person has come to know? Because he has asked his customer by that simple survey, how did you come to know about us? And customer has just put a check mark. So now he knows that this much sale is coming every month due to this channel, this much sale is coming every month due to this channel, and so on. So he gives last 48 months data. Now the problem is, if that data is 100% perfect, then it is okay. But sometimes that data is totally, the data is unclean. Unclean means what? I have given one example at the bottom. So this is a synthetic data creation. Data creation is not important, but this data is created. Now you can see here itself that in the customer name itself, there are some null values. So that means this customer, while filling up the form, he forgot to put his name. In the gender of the customer, because suppose you are your client is a fashion business, so he would like to know that whether the customer who has given feedback is of male gender or female gender. So male, you had given only 3 choices to the customer in the form: male, female, and other. Okay, here male, female, other. But some other random choices, because here I wanted to generate the data. That's why these other random choices, unknown, alien, non-binary, they also came. So I generated this data, and at that time I gave some condition that gender must be filled with male, female, other only. But then I said that there should be 3 rows with gender, which should not be male, female, and other, but some strange strings. So there may be some clients who do not want to disclose their gender, so they just write any fake or random things like non-binary, alien, or whatever, or maybe unknown or whatever. They don't want to disclose. Okay, fine. Then similarly, I put the condition while generating the data that education of the clients must be doctorate, postgraduate, graduate, and undergraduate only. But some clients did not read that you have to write from these choices only, and they wrote. Let me first execute this so that entire data set is visible. Okay, so they wrote elementary, none, no education. But you ask that you please select only one of these 4 choices. Okay, these 4 choices. This doctor, postgraduate, graduate, and undergraduate. Okay, so the clients have filled up random values. Similarly, there are non-values. Some clients just left the blank empty. Income was the table, and some may not prefer to disclose their income, so they write the field blank empty. Then similarly, age somewhere is there. Now one person has written age 190. One person has written age none, so he forgot to write his name. This is age 170. This is somewhere negative age. Similarly, in the income also, one person has written his income to be minus something. This also has written minus something. Now these all are called issues with the data. So the client provided me data, and he tells me that this is my problem, this is my data. You solve my data, my problem. But with this kind of data, you cannot directly start your data science or model building. So what you have to do first is you have to do understanding of data, exploratory data analysis, so that you come to know that these kind of values are there and negative values are there and some outlier in the age are there, 190 years and etc. And second thing, then you have to do data wrangling. Data wrangling means you have to solve that problem, that ideally there should not be negative income. So, but negative income values are there. So either you drop those rows, or maybe you uh, uh, fill that negative value by the median income of the other observations. Okay. Similarly, gender also should not have those random alien and etc. values. So either you drop those rows if you have sufficient data, or fill by mode. That is the most frequent answer, male or female or other. Okay. And that way you make your data clean. So data acquisition, that was our one chapter, how Pandas can read data or load the data from CSV file, TSV file. It can read the data from Excel file. It can read the data from databases, SQL or MongoDB or any other database. It can read the data from internet. If that data can be even big data, Parake, HDFS file. Now you are understanding your data. That was exploratory data analysis, which we had done in previous chapter. But understanding is not enough. Understanding will just explore the data, and it will tell you that this kind of data is there. Now what to do with these kind of values? You cannot blindly drop all rows, because many times data is very precious. So each time you drop a row, you are losing one information. So better approach would be somehow treating the data in such a manner that all these observations become acceptable. Acceptable. Okay. Except there may be few rows which are duplicate. That means by mistake the client had given, customers filled up the form which was in paper form, and your client had one employee who did the data entry in Excel sheet, and by mistake same form was maybe filled up 2 times. So exactly same social security number came 2 times. Now obviously social security number cannot be repeated. So that duplicate data rows you have to eliminate. But apart from that, no other rows should be directly eliminated. As each elimination should be done as a last recourse. You should be able to do something so that invalid values come within the acceptable range. So if you find an age is 190, then you should not just say that let's drop this customer's data, because that customer has given his choices. So that is useful information. So maybe he was writing 90 and 190, or maybe the data entry operator who entered in Excel sheet made from 19 to 190. So you have to replace that data by maybe median or mean, depending upon some strategy. This whole business of bringing the data to acceptable form for the next stages of data science life cycle, that is this feature engineering and model creation and all that, that is itself called data wrangling. It is also called data munging. Okay, data munging, M-U-N-G-I-N-G. So this chapter is how to do data wrangling. And remember that there have been automated methods for everything nowadays, but still a person can show his skill in this data wrangling and in this feature engineering, and these two are still left to the skill of the data scientist. And of course, hypothesis formation. What do I say by hypothesis formation? When client came with this problem, first you don't immediately start making such equation with unknown. First you make a hypothesis that first of all, does the sale depends at all upon TV marketing? So you make two hypotheses. One is called H0, null hypothesis, which says that sales does not depend upon TV marketing, and another is, say, alternative hypothesis H1, which says that sales changes when TV marketing budget changes. Okay, and then you have to decide by certain tricks that which hypothesis is correct on the past data, based on which at least you come to know, suppose that yes, TV marketing budget is effective. So that means that TV marketing budget does change the sales. Alternative hypothesis is correct. Same, you will make null and alternative hypothesis for radio, null and alternative hypothesis for newspaper, and null and alternative for social media. Null in all three cases may be said that sales does not change with this, and alternative means the sales does change with that. Now suppose by chance the past data when you studied, you came to know that actually speaking, this radio marketing suppose does not have any effect at all on the sale. That means sales varies, but that variation can be perfectly explained by these three only. While whether one spends less or more or same amount in 2 consecutive months on radio marketing, the sales due to radio marketing just randomly varies. It has no pattern by which I can establish a relation between my budget on radio marketing and sales. Then you can tell your client that simply drop this marketing channel, because you are just feeling that sometimes sale is increasing, sometimes sale will decrease also, but that is just randomly changing and it has nothing to do with radio marketing. Instead of that, better spend this $5 million somewhere here. So a data scientist work where it cannot be replaced is in converting business problem to data science problem. That is a skill you have to communicate with business owners and the senior business managers. Then second is converting forming appropriate hypothesis. Okay, and then this data understanding and feature engineering and this data wrangling, they also require some original thinking, and everything in this cannot be automated. Though many things can be, but everything cannot be automated. So there is still some room for us data scientists in the current era of AI. So I wanted to take this for actually the second lecture maybe or first lecture, I don't know, but introductory lecture, because that gives the idea of what we are going to do in entire chapter. So our chapter will begin from the here introduction to data wrangling in the next lecture. Thank you.